Next, the topic is simple microscope. Simple microscope. The simple microscope, that is also called as magnifying glass. And we know the magnifying glass that produce a magnified image of an teeny object or minute object. If you place a dot here and you observe this with the help of a magnifying glass, then you can observe it is a large one. So we can say the simple microscope or the magnifying glass that produce a magnified image of one minute or teeny object. And we can say the simple microscope that consists of a converging lens, or the converging lens means it is the convex lens. The convex lens is converging in nature. Clear? So, in the image formation by a convex lens, we have already discussed that when the object is placed close to the lens, in that case you can find a magnified, virtual and erect image. Here, if this is the converging or convex lens, this is the optical center and this is the principal axis. Where this is the optical center C and this is the F1, first principal focus, and this is F2, second principal focus. And when we place an object close to the lens, that is in between the focus and the optical center, let the object is situated here A, B. Then one of the ray that passes parallel to the principal axis, after refraction through the lens, it will pass through the focus. So the ray will follow this path. Then another ray which passes through the optical center, it suffers no refraction. That means there is no deviation in its path. Let this is the ray that passes through the optical center, and here, so no deviation in its path. So in this side, the two rays, they separate away from each other, and when you extend these two rays in the opposite direction, means in this direction, you find the two rays, they appears to meet here. So this is the image. Let this is B dash, this is A dash. So we can say this is the virtual image, magnified and erect, which is formed on the same side of the object. Clear? So here we can take this distance as the object distance and this distance as the image distance V, and this is the diagram of a simple microscope. That means we have to use a convex lens and we have to place the object close to the lens, then we can see a magnified, virtual and erect image of the minute object. That means your eye is placed here. Let this is your eye. This is your eye. So you can see the image form at a distance B. This is the diagram of simple microscope. Clear? And in case of simple microscope, we know when the object is situated at a distance of distant vision, we can see it clearly. That is 25 centimeter. When the object is situated at a distance of distant vision, we can see it clearly. So here we can take here we have to take to see the image clearly. We have to take the image situated. The image is situated at a distance of distant vision. That's why we can take B is equals to D. This distance is equals to D. Clear? And actually, the object that is situated at a distance U, what to see it clearly, we have to imagine the object is situated at a distance of distant vision. So we have to imagine this is the object which is situated at a distance of distant vision, that this is A double dash B dash. Clear? To see the object clearly, we have to imagine the object is situated at a distance of distant vision. That's why we have to imagine the object is situated at a distance D. That is A dash, A double dash, B dash is the object. And when you join the tip of the object, that is A double dash with C, you can find here, you find an angle. Let this angle is alpha. That means we can say the angle subtended by the object at the eye is alpha. Clear? And this is the another angle, that is the angle subtended by the image at the eye. This is beta. Yet this is beta. Clear? That means this is the height of the object and this is the height of the image. That means we can say here the image is angularly magnified. There is a angular magnification of the object. So here we have to use the term angular magnification. That is also known as the magnifying power. So the magnifying power or angular magnification, that is m. So the formula of magnifying power or angular magnification, that is the angle subtended by the image at the eye to the angle subtended by the object at the eye. So here you can observe the angle subtended by the image at the eye is beta, clear, and the angle subtended by the object at the eye is alpha. So we can write m, the angular magnification or magnifying power m, that is equals to beta divided by alpha, clear. So we have already discussed for smaller angle, when the value of the angle is small, for that case, for smaller angle, tan theta we can write that is nearly equals to theta, or we can write theta that is nearly equals to tan theta, or you can say sin theta. So here in place of the angle beta we can write tan beta, and in place of alpha we can write tan alpha. So here we can write that is tan beta divided by tan alpha, clear. So in the angle ABC, in the angle ABC, tan beta, the value of tan beta is, this is the angle, so tan beta will be AB divided by BC, and in the triangle A double dash B dash C, the value of tan alpha, that will be equals to A double dash B dash divided by B dash C. So we can write A double dash B dash as AB, same height, same length, so we can write that is equals to AB divided by B dash C. So here tan beta, that is equals to AB divided by BC whole divided by AB divided by B dash C. That implies the magnifying power M will be equals to AB divided by BC into B dash C divided by AB, and AB cancel, and we can write that is equals to B dash C divided by BC, clear. So what is B dash C? B dash C is the image distance V, and the image is situated left to the lens. By using the sign convention, it will be negative, that is minus V. And what is BC? BC, that is the object distance. Again, the object is situated left to the lens. By using the sign convention, it is minus U. That implies we can write m, that is equals to v divided by u. Magnifying power or angular magnification of simple microscope or magnifying glass. And we know the lens formula. Lens formula by using the lens formula. What is lens formula? That is 1 divided by f, the focal length, that is equals to 1 divided by v minus 1 divided by u. Clear? And here we want v divided by u. So we have to multiply this equation with v to get here v divided by u. So now multiply this equation with v, that implies v divided by f, that is equals to v divided by v, that is 1 minus v divided by u. Clear? That implies, what is v divided by u? That is m. That implies here v is equals to d. So we can write in place of v, that is d, the distance of distant vision. That implies d. So d, that is minus. So you have to put a minus sign here. D divided by f, that is equals to 1 minus m. That implies taking m into this side and d divided by f into this side. That implies m will be equals to 1 plus d divided by f. This is the formula of magnifying power, where d is the distance of distant vision and f is the focal length. Clear? So this is when the eye is close to the lens. Yes, when the eye is not close to the lens. Clear? For that case, that means the eye is situated at a distance, let a. The eye is situated at a distance a. For that case, when the eye is situated at a distance a or anything else, let a from the lens. For that case, the magnifying power, when the eye is situated at a distance a from the lens. For that case, the magnifying power m will be equals to 1 minus, this is plus d minus a divided by f. Clear? This is the formula for when the eye is situated at a distance a from the lens. Clear? So the basic formula is m is equals to 1 plus t divided by f. So from this equation we can observe when the focal length increases, magnifying power decreases, and when the focal length decreases, the magnifying power increases. So we can say, to find a magnified image, we have to use a lens having small focal length. Clear? To find a magnified image of the object, we have to use a lens having small focal length. Clear? And remember, the simple microscope that magnifies maximum up to 10 times, that is m, that is maximum up to 10 times. Clear? And when the another case, when the image is formed at infinite. Clear? And in the formation of image by the lens, we have already discussed when the object is situated at focus. For that case, the image is formed at infinity. So, the case when the image is formed at infinity, for that case we have to take the object distance u is equals to f. U is equals to f. Clear? And v is equals to infinity. Then the magnification m. The magnification m will be here. Yes, tan beta. That will be AB divided by BC, and tan alpha is AB divided by B dash C, and M is equals to B dash C divided by BC. The magnifying power that is equals to B dash C divided by BC. So what is B dash C? B dash C, that is B dash C, that is when the image is formed at a distance of distinct vision, we can see it clearly. So B dash C will be D, and BC, for that case the image is formed at infinite, means the image should be situated at focus. So here BC, that is the object distance, and you can take this as V. So the formula of magnifying power or angular magnification, that will be D divided by F. That is when the image is formed at infinity. Clear? So this is about simple microscope or magnifying glass use. So next is use. So where we use the magnifying glass? Where? In watch shop. To repair the watch, we have to use the small parts. To see the small parts of the watch, we have to use the magnifying glass. Clear? And in jewelers, to do the verified works in jewelry, the jewelers, they use the magnifying glass. Another most important use is students. Yes, in physics practical, the science students in practical class, they use the magnifying glass to measure the vernier scale reading. You know the vernier caliper, very small scale is there. To watch it in magnified form, we have to use the watch glass or magnified glass. Clear? So these are some use of simple microscope or magnifying glass. And here you can find a very sharp image as the object is situated to the lens, and in some cases there is some defects. As there is a single lens, there are some defects. So sometimes the image form may be bluer. For that case, we have to use two such type of lens, and that is the next compound microscope, and we will discuss it next class. Compound microscope. Clear? So this is all about simple microscope, derivation, and the derivation for magnifying power or angular magnification and use. Important, you have to remember, note down.